Welcome back to Python class. Here we are in chapter 2, and we're going to start off talking about values and types. This is, it's very straightforward. We have a value is an item that has a value. So it is an actual letter or number or string or something like that. So a specific number or string or something is a value. Um, and there are different types of values. There, so far you have encountered integers and strings. Now there are other types that you need to know about. You need to know about floats. So a float would be a decimal number. Now, a lot of languages that you're going to encounter are very strongly typed, and you have to, when you declare a variable, you have to tell the language or tell the compiler, you have to tell the program what type of variable you're making. So you can't just say, okay, x equals 5. You have to tell it whether x is an integer or a float, or sometimes even more precise than that, how big of a float or how big of an integer. Python figures that out for you. It's a very kind language. And it will even change it for you. So, for instance, oh, by the way, if you haven't noticed, within this is the same textbook you have, and within it, it's got some trinket consoles, and you can you can program right here in this console. This is an interactive console, so you can see here that it said what is the type of hello world and what is the type of 17. Comes back and it tells you that hello world is a string and 17 is an int. So you can also do something like say, okay, x equals 5. And now you could say, what is the type of x? Oops, I didn't actually close parentheses that. All right, let's try this again. X equals 5. Type x. So that is an integer. Now let's say x divided by 2, or sorry, x equals x divided by 2. So what is x now? X is 2.5. That's not an integer anymore. And sure enough, if we say type x, it's a float now. Python did that for you. It figured it out. So you don't really need to worry too much about whether something is a decimal or an integer. You do need to know the difference between strings and numbers. And you think, oh, well, of course, a string is something like hello world or hi, I am an alien. And an integer is like 3. Well, what if you do this? X equals quote 3. Oh, what did I do? Oh, I just down. Page down. Okay, so x equals quote 3. What is x now? It's a string because I put that in quotes. So 3 in quotes is not the same thing as 3 without quotes. You need to get used to that. Okay. Okay, something else you need to get used to is that an equal sign is not exactly what you're used to from math. An equal sign here does not mean that what's on the left side of the equal sign is the same thing as what's on the right side of the equal sign. This is an assignment operator. A single equal sign is an assignment operator in Python. So what this literally means is here we are assigning the value, and now for something completely different, to a variable called message. Here we are assigning the value 17 to a variable called in, and here we are assigning 3.1415 blah 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 to a variable called pi. So that is absolutely not the same thing as simplifying an equation and you've got stuff on the left equals stuff on the right. It is an assignment. Okay. What else do you need to know here? Okay. Variable names and keywords. You can use letters and numbers and underscores. You can use capitals and lowercase. There will often be in a particular environment, and by environment I mean like a workplace or some teachers really care how you name variables. I do not care so much. I am not going to say you have to use this convention where you use a word and an underscore and another word. Sometimes you might want to write, you might want to have a word and then instead of an underscore, then you would use a capital N. So my name without the underscore here. That is also acceptable. It is pretty much everywhere it is a convention that you start variables with a lowercase letter. Sometimes you have a named constant, something like say pi that will always have the same value. You're never going to say, well, okay, pi is going to equal pi times 2 now. No, it doesn't work that way. Pi is a constant, but it's also a big, ugly, long constant, and you don't want to be typing in 3.14159, blah, 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 blah. So you can, if you need to be working with pi, you can make that a named constant. And so it is almost always a convention that you will name constants with a capital letter. It doesn't make a difference to Python. It's just a convention. Okay. So you cannot start the name of the variable with the number. So you see here some examples that throw errors. You can't call something 76 trombones because it starts with a number. You can't use, let's see, what else did they do? Oh, you can't use more at because that is an illegal character. But what about something like the word class? You would think that would be a variable you could use and, say class equals English, class equals Python. But no, that is a reserved word. So there are some words that mean special things to Python and you cannot change them. So it's not a very long list. You should get pretty familiar with this. Some of these you're going to use all the time. So I don't think you're ever going to try to name a variable and. Some of them you may rarely or even never use, like I don't think I've ever used lambda or yield. But some of these you're going to use all the time. At any rate, you're not allowed to use any of these 33 words as variable names. So if you get an error that looks like this, syntax error, invalid syntax, and it is pointing to a line where you assigned a value to a variable, and that's all it tells you, chances are you just picked a poor variable name. So I would start with that in debugging. A lot of Python errors are more helpful than you will find they are in other languages, but this is one that's, it doesn't tell you that this is a reserved word. It just says invalid syntax. It says, I don't know what to do here. So, okay, there you go. Statements, operators and operands. The operators work pretty much like you expect them to. Plus, minus, the asterisk for times, the forward slash for division, and 2 asterisks for exponentiation. So some languages will do that with a caret, but this is pretty common. A lot of languages will use it this way. So 5 splat 2 means 5 squared, 5 to the second power. So the division operator, this is another instance where Python is very kind to you. You can, like I showed you up before, that you can have an integer and you divide it by something, and if the answer is a float, well, that's okay, it doesn't care. Well, what if you want integer division? What if you want something like in elementary school and you want to find just the whole number part and have a remainder? Well, that would be 2 slashes. So if you say what here is minute div 60. That's going to give you 0. And you think, oh, wait, but what? It should round to 1. Well, this is not rounding. This is just the whole number part. So if you say 5 div 3, so that is integer division. What is 5 divided by 3? It is 1 remainder 2, right? So that's going to tell you it's 1. Well, what if you want the remainder? That would be modulus. So 5 modulus 3, that's going to give you the 2. So sometimes you need to know that. An expression can be a straight literal value, it can be a variable, and it can include operators. So a value all by itself is an expression. So 17 is an expression. A variable all by itself, x, is an expression. Or the operation x plus 17 is also an expression. So those things are expressions. And if you're in interactive mode in Python, the interpreter will evaluate it and display the result. So if Python already knows that x is 2 and you type in x plus 2, it's going to tell you it's 4. But in a script, so in a program, an expression all by itself doesn't do anything. That is it's got to be assigned to something or put in a function. You got to do something with it. So we will get to that more a little bit later. Order of operations, you should remember this from basic math. It does work exactly like it did in arithmetic. If you need a refresher, here you go. Anything in parentheses will have a higher precedence than anything outside the parentheses. So you should do inside first. You should do multiplication and division before addition and subtraction. And you should do exponentiation before multiplication and division. So if it's not clear, you should use parentheses. Because unless you're doing one of those silly Facebook puzzles, nobody wants to answer 2 plus 3 times 4 divided by 6 times 3 plus 1 to the squared. You know, it's nobody wants to deal with that. Okay, all right. We already went over modulus. Something you need to know about string operations is here the plus sign is not addition, because if we have, okay, I'm sorry, right here we have a couple of integers. First is a variable that is assigned 10. Here, second is a variable that is assigned 15. So if you add them, that is 10 plus 15. You print that out, you get 25. But then we change first to be a string of 100 and second to be a string of 150. Printing first plus second does not add them, because remember, when you put this in quotes, it's not a number anymore, it's a string. So this is actually, we call this the concatenation operator now. So the plus sign is used as a concatenation operator, and Python just knows what to do. However, you cannot use the plus with a number and a string. So if you try to say print quote ABC quote plus just the number 3 without quotes, it's going to give you an error because you can't do that. Okay, next thing we need to do is talk about input. So you know how to do output now, that is the print statement. But what about how do you prompt a user for information from them? Well, that is the input statement. And you can give them a prompt inside your input function. And this statement right here does a whole lot of useful things. And this is another one of those places where Python is very kind to you and other languages are not so much. But you have here the prompt, what is your name? You have a \n, which is a line feed, carriage return, new line. And you have that this is input. It wants you to get this input from the user. And it has a variable that you're assigning this to. So when you type this in, this whole statement, name equals input, what is your name? Python will display what is your name, and it will wait for the user to type something in, like Chuck. Then you can say, okay, now we have a variable called name. What is stored in name? Chuck. Chuck is stored in name. So that is how you do input in Python. Now you can also do this in different steps. You can create a variable called prompt, and you can give it a text string. What is the airspeed velocity of an unladen swallow? And then you can just give it, then you can just say, okay, here's a variable that will ask for the input, and here is the prompt. So instead of typing this string in here, you put it in a variable, and then you use the variable in your input statement. That is exactly the same thing because prompt has been assigned this value, and now you are inputting that value or using that value in the input call. Okay, now here's something important. When you store input into a variable, it is always going to be a string. Even if you're asking somebody to input an integer between 1 and 10, it's still going to be read in as a string. So what if you need it to be a number? This is how you convert it to an integer. So they said 17. Well, this now is the string 17. Here, you're converting it to an integer. So now you have an integer stored in speed and you can do math on it. So you can say int speed plus 5, and that will be 22. Now, in the program, you're not going to just say int speed, right? This is at an interactive prompt. So in a program, you're going to want to do something like say, okay, actual speed equals int speed, right? Because that's going to give a new variable that you know is going to be an integer, and then every time you can do your math with the integer, and you know that that's an integer, and it's not the string that was input anymore. And you only have to do it once. Okay, so if you assign this to a variable, a new variable, so let's say actual speed equals int speed, you do not have to use int actual speed anymore. Does that make sense? You've already converted it. You don't have to convert it again. So you are not going to have to say, okay, int actual speed plus int 5 equals something, right? It's already been converted. You don't have to do it again. Okay, what else do we need to talk about? Comments. You have already seen what a comment is, and I will tell you, I'm asking you to put a heading on every program that is a comment with your name and the name of the class and the date and the name of the program. It's not that I'm going to print this out and I need to know whose program it is. And it's not that I'm going to forget what class it is, and it's not that I'm going to forget which program you're doing. It's all right there in Trinket for me. I can run it right there just like you can. So that is not an issue. The reason I'm doing that, it is somewhat arbitrary, but the reason is attention to detail. It's just a small detail. It's not like I'm asking you to do something that's going to take you an hour, but attention to detail is very important for a programmer, and that can make the big difference in whether you have happy users, happy boss, or unhappy ones, and perhaps no job. So pay attention to the details of what you're being asked to provide. I am very sticky about that. If I ask you for a particular format of output, it needs to be that way. Okay, so comments. I do not insist that you comment every single line of code. That is kind of stupid. Although, I mean, if you call all your variables things like A, B, and C, then yes, you've got to comment it, because what are those things? But if you use meaningful variable names like percentage, minute, things like that, then you don't have to tell me that a percentage is the minute divided by 100 or something. I mean, it's it's obvious what that is. Okay, in a simple operation, you don't need to comment on every single line. But if you're doing something complicated, it's really useful to give a simple comment there, and you can do it on the line all by itself like this, or you can do it after the code on the same line like this, and either one of those is fine. But you will learn that no matter how good your memory is and how well you understand what you're doing on any given day, when a month goes by and then you come back and look at your code, you're not going to remember what exactly every single thing was. So anything that is a little bit complicated, you need to put a comment on. Okay, that's enough of that. So debugging, we have, yeah, not a whole lot of things that that you're going to have trouble with debugging right now. You should know what all of these terms mean at the end of the chapter, and you should be able to do all of these exercises. I am not going to do these because this one is a whole lot like your homework, your programming assignment. So I'm not going to do that for you here. Let's see. We can go over exercise 4 though. Let's do this one. Okay, so exercise 4. So here I have a Python shell up. You can do this in a trinket if you want to. I'm just going to use this. So they want us to say width equals 17 and height equals 12.0. Okay, so what do we know about these so far? Width is an integer and height is a float, right? So what do you think is going to happen when we type width divided by 2? I'm sorry, integer div 2. That's how we tend to read that. So what do you think is going to happen here? This was the integer division, so this should give us elementary school 17 divided by 2, right? So with the remainder. So what is 17 divided by 2? That is 8. It should tell us 8, right? Yes, it does. Now what if we say width divided by 2.0? Okay, now we've got an integer divided by a float. So I think it's going to give us back a float. And what do you know? It does, 8.5. How about height divided by 3? Well, now 3 is an integer, but height is a float. So what's it going to do? Well, I think it's going to default to float because height was already a float, so it's got a little more precision. So sure enough, we get 4.0. Okay, now in number 4 here, this is kind of odd, and I think they actually didn't really mean it to go exactly like that, because if you just type this on one line, 1 plus 2, backslash times 5, it's going to give you an error because that backslash is the line continuation character. That's what you use in the interpreter if you need to carry on the next line, because it's going to, if you hit enter, it's going to think you're done with that line. But what if you've got a really long expression and, you know, maybe you've got some really long variable names or something and you can't get it all on one line? Well, that's when you use the line continuation character. So the way this should really work is 1 plus 2. Let's continue on the next line. So you notice that we didn't get another prompt here because now it knows that we're continuing to type what we started on the first line. So now we can enter the times 5, and we know what our order of precedence is. 1 plus 2 times 5, what's it going to do first? It's going to do 2 times 5 first, right? So that's the same as 1 plus 10, which is 11. Now, I don't expect you to be able to do all kinds of math in your head, but you should always have an idea of what your program's going to do and be expecting something so that you're not, don't just assume that it's going to get it right, because while Python's not going to make a math error, you might make a mistake in what you tell it to do and not realize it. So you might have meant what is 1 plus 2 times 5, what is 3 times 5. So if that's what you really meant and you type this in and you didn't really think about what the answer was supposed to be, then you might not notice because it didn't give an error. And that would be called a semantic error. So 1 plus 2 times 5, because it's not a syntax error because Python knows how to execute that. You have just communicated with Python. But if that's not what you meant, then you miscommunicated. If this is what you really meant. I'm sorry, I just said that wrong, didn't I? If this is what you really meant, 1 plus 2 times 5. There we go. Yeah, that's what you really meant, then you need to expect it. You need to always test your program to make sure that it does what you think it should do. Okay. Okay, and the last exercise there is, it says write a program which prompts the user for a Celsius temperature, converts it to Fahrenheit, and prints out the converted temperature. Okay, let's try this one. So let's do this one in Trinket. Let's get us a new Trinket here. Come on, Trinket, wake up. All right, home. New Trinket, Python 3. Now, if I wanted to get an interactive prompt like we were doing before, you can get that. Let's see, where is that in here? Now, there's some way to do this. Oh, there we go. Console right there. That would be how we were in interactive mode before, but that is not what we do here. We just want it to be in. We want to write a program. So okay, so there's my header. The first thing I need to do is prompt the user to enter a Celsius temperature. I'm going to call that cell temp equals input. Please enter a Celsius temperature. And now, so now once we run this, we're going to have a variable called cell temp that's going to have what in it? A string, right? So we need to change that. Okay, and since we're going to be doing math involving fractions and stuff, we probably want to use a float and not an int here. So let's make it a float. Now, we can do it here. We can also put it right here and do this in one step. So when you have two sets of parentheses like this, Python's going to do them from the inside out. So it knows, first of all, it knows that this is your prompt, and then it knows that it's going to do the input of this, and then it's going to take the results of that and turn it into a float. So we've just done that all in one step. Now we have our Celsius temperature, and now we need to convert that to Fahrenheit. So var temp, let's start this with the lowercase, even though Fahrenheit is normally proper. Var temp equals cell temp times 9 divided by 5 plus 32. Yeah, that should be right. And now we need to print it out. So now let's print var temp. And let's run it and see what happens. Let's see. Let's put in 100 because we know what 100 degrees Celsius is. It is 212 Fahrenheit. That is the boiling temperature of water. So that worked. How about, let's see, what is that magic one? Negative 41, I think. Let's try that. Negative 41. Oh, nope, that wasn't quite it. It was pretty close though. All right, so there you go. There's a couple of examples for you. And as always, let me know if you have trouble. I am here to help you. Have fun.